Okay, students, so today we are factoring and solving polynomials. So the way that we're going to factor, part of our objective is we're going to use these different forms of factoring. We're going to use the quadratic form, the basic form, grouping, and sum and difference of cubes. Now we've done grouping before and we've done sum and difference of cubes, but we'll review that. And then we're going to solve. So we're going to solving. You can call it the roots, you can call it the zeros. So we're going to find those roots or those zeros or the solutions for these polynomials. So let's look at our first polynomial that we're going to factor, and we're going to factor this using quadratic form. Okay, so the first thing is you have to recognize if this is quadratic form. So the first thing is it must be a trinomial. So count this, 1, 2, 3. It's a trinomial. Okay, that works. Second, all exponents must be even or 0. 4, 2, 0. That works. The first term exponent is double the middle term exponent. Well, we have 4 and we have 2. So that works. Now I put specifically for the first term variable, so we're talking about just this x here. So that's x to the fourth, x squared. Okay, so now let's look at our steps for this. So our steps is pretty easy. If we are going to factor this, then we can use any method that you've used for factoring up till now. But up till now you've only factored quadratics. So let's use the diamond method for this. So the diamond method, you have the sum goes down here and the product goes up top. So the product right here is 20 and the sum is 9, so I'm going to put 9 down here. Then you ask yourselves, what two numbers add to be 9 and multiply to be a positive 20? And the answer to that is 5 and 4. So when I factor this, I'm going to set it up, but now note that instead of just x's, I have an x squared. That's the difference. I get 2x squared because x squared times x squared is x to the fourth. So we only have positive signs. I'm going to keep my two positives, and I'm going to put in my two factors, 5 and 4. So therefore, this polynomial factors down to this. Okay, so I have this factored. Now, if you look at this, we could go farther if we had to solve for this, because each one of these is a quadratic. So this could, if this would be equal to 0, we could solve these, and we can solve this like so. If I change my objective now to solve, I could solve each of these by setting each one of these equal to 0. So I'd have x squared plus 5 is equal to 0, and I would have x squared plus 4 is equal to 0. And for solving these, I just have to subtract 5, take the square root of both sides, and I get a plus or minus square root of negative 5, which equals to plus or minus I times the square root of 5. This one, I get x is equal to plus or minus the square root of negative 4, which becomes 2i. Notice here that I have 4 solutions because of this plus or minus, and I have 4 imaginary solutions. So I can always know how many solutions I'll get by this leading degree. So I have 4. Okay, let's continue on with this. So note that we have to factor in order to solve these. So let's work on this one, and I'm upping my objective from just factoring to solving. So I need to solve these. So we're going to factor, though, using basic factoring techniques. So for basic factoring techniques, what you need to do is recognize it, and that's, is there a common factor you can pull out? Okay, is there a common factor you can pull out? For here, x cubed minus x squared minus 20x is equal to 0. There is a common factor. All of these have an x term, so I'm going to pull out the x term. And I'm left with x squared minus x minus 20 is equal to 0. Okay, now, if there is, then can you factor what is left over? Can I factor this? Does this factor down anymore? And it does. So I can factor that. This factors, like again, I can do the x, the diamond method, or I could do the, I prefer the process of exhaustion, just trying different options. But I'm saying what two numbers multiply to be negative 20 and add to be negative 1, and the answer to that is negative 5 and positive 4. So this becomes x minus 5, x plus 4 is equal to 0. Okay. So now that I have that, let's continue and solve this. So now when I'm solving, each one of these is going to be set equal to 0. The spear's back. So I'm going to set the x equal to 0, the x minus 5 equal to 0, and the x plus 4 equal to 0. Let's get rid of this. You can see the steps. Okay, so let's see what we've already factored out the greatest common factor. We factored the remaining quadratic, and now we're solving by setting each of these equal to 0. So this one's already done. We get x is equal to 0. This one we get x is equal to 5, and this one we get x is equal to negative 4. So these are my answers, and we notice that we have 3 of them, and that was the highest degree here. So that works out. Okay, let's look at another one. Okay, this one is solving. So again, we're solving. This time we're factoring by grouping. So again, you have to recognize, can I factor this by grouping? So if I look at this, the first thing is there has to be 4 terms. This will give it away. There's 1, 2, 3, 4 unique terms. So that works. Now it must have a common factor for 2 of the terms. So if I look at this, can I factor out something from these? And the answer is yes, I can factor out in x squared. So I'm going to factor out this x squared. And what I'm left with is x minus 2. And I still have this plus sign. And over here I have x minus 2. And I'm going to put parentheses around that so you can see the next one. Okay, now once greatest common factor is factored out, 2 of the terms must be a repeating binomial. So I do have this repeating binomial. I have x minus 2 and x minus 2. So to solve this, we are going to factor out the greatest common factor. That was the x squared, just out of these 2 terms. This one didn't have a greatest common factor. So think of it as if we just had a 1 out here. Okay, now we're going to factor out the remaining repeating binomial. So since we had this x minus 2, let's factor that out. So I have an x minus 2, and what I'm left with is x squared plus 1 equal to 0. Let's just show that. This x minus 2, I factored it out, and then what was left over was this and this, so that was this. I factored this out. can think of it, factoring is doing that backwards. X minus 2 times x squared is this. And then x minus 2 times 1 is this. Okay, so now we have this. Now we just have to set each one of these equal to 0. And solve. Solve by setting each factor to 0. If one factor is a quadratic, solve accordingly. So we have that right here. So let's look at this. This one's easy. All I have to do is add 2 to both sides. Bam, I have one answer. This one, when I subtract 1, I get x squared is equal to negative 1. So this one I can solve this quadratic just by taking the square root of both sides, and I get x is equal to plus or minus the square root of negative 1, which is equal to plus or minus I. Notice this plus or minus makes that 2 answers. So I have 2, 3, and my original equation was the third degree. So that's why I have 3 solutions. Alright, let's do a couple example problems. So this example problem, this is solving with basic factoring because I recognize that I can pull an x out of everything here. So let's go through, pull an x out. I'm left with x squared plus 8x minus 21 is equal to 0. Okay, right here I have, this is already factored, but oh, what about my x squared plus 8x minus 21? That's a quadratic. So we can solve that. So let's solve that quadratic over here. And let's do it by completing the square. We can use completing the square. If it factors, we could factor. But this one doesn't factor. So completing the square always works. Quadratic formula also always works, but I prefer completing the square. So the first step for completing the square is let's write it in the form ax squared plus bx is equal to negative c. And now let's complete the square. So I'm going to have x squared plus 8x plus half of my b value squared, so that's 16, is equal to 21 plus 16. This is the completing the square part. Now this will always factor to x plus whatever your b value over 2 was, so x plus 4 squared. And I'm going to combine that. So 21 and 16 is 37. Alright, now I have to just solve this. I'm going to take the square root of both sides, and I get x plus 4 is equal to plus or minus the square root of 37 by square rooting both sides. And my final answer is x is equal to negative 4 plus or minus square root of 37. Now that we have that, let's just set each one of these equal to 0. So I have x is equal to 0. Then I have these solutions. So over here, we have the solution of x is equal to negative 4 plus the square root of 37. And we have x is equal to negative 4 minus the square root of 37. Again, third degree, and I have 1, 2, 3 solutions. Alright, now remember that these solutions represent where the object crosses the x-axis. So what this says, since these are real, that this graph, it could look like this. So I'll just do this really quick. It's a cube, so it could look something like this, where I just need to draw this a little bit over because we know it passes through 0. So we have negative 4 plus the square root of 37. Now this isn't exact. This would be roughly negative 4 plus 6, so this is about positive 2. And this is negative 4 minus 6, so that's like negative 10. So we see that it crosses. This isn't exact at all. It would be more like this, down to negative 10. That would be a better approximation. You have to move that point out here. So at negative 10, and this one is about 2. So this is a rough estimate of what this graph looks like. Okay, that's what we're solving for. We're solving for these zeros here, or roots. Okay, let's do one more. This one is, we need to factor this, but if you notice, let's start off with basic factoring, and when I start off with basic factoring, I can pull an x out. That leaves me x cubed plus 64 is equal to 0. And now you should notice that this is a perfect cube and this is a perfect cube, so I have a sum of 2 cubes. So this was the other day's lesson. So that would become x plus 4 and x squared plus 4x plus 16. All that equal to 0. Now if you are confused on how to do this, watch the previous video on how to factor sum and difference of cubes. And I made an error there. This is a minus sign because of SOFAs. So SOFA says that there's an opposite sign. Square the first, opposite sign, first times the second, always positive. Square the second. And now I set each one of these equal to 0, so I have x is equal to 0, x plus 4 is equal to 0, and I have this one, x squared minus 4x plus 16 is equal to 0. Okay, this one's solved, so I have this as one of my answers. This one I can solve by subtracting 4. I have 2 answers. I have 1, 2. Now I get my other 2 roots from this one. So let's solve this, and let's solve it by completing the square again, so you get a lot of practice doing this. So half of negative 4 is negative 2. Negative 2 squared is 4. So I'm going to add 4 to both sides. Now I'm going to factor this. That becomes x minus 2 squared is equal to negative 12. I take the square root of both sides. That gives me x minus 2 is equal to plus or minus the square root of negative 12. Now I have x is equal to, I'm going to add 2 to both sides, so 2 plus or minus, and now let's simplify this. I can pull an I out, also I can pull a 4 out. Square root of 4 is 2, so I get plus or minus 2i times the square root of 3. And here's my 2 answers. So my other roots or zeros is 2 plus 2i square roots of 3, and x is equal to 2 minus 2i square roots of 3. And what that means is I have these 4 answers, but only 2 of them cross on the real coordinate grid. The other 2 cross in the imaginary. So out of this I have 2 real solutions. So these are real, and these are imaginary. Still solutions, but just in the imaginary realm. Okay, you'll have a lot of practice for this on your worksheet, and let me know if you need any help.